Hi everyone, this is Sridevi, Professor, Department of Electronics and Communication Engineering, Rohini College of Engineering and Technology. Today, in this session, we are going to learn about Foster-Seeley Discriminator. On completion of this module, the learners can easily able to understand the modulation of FM signal, and also they can gain knowledge about FM demodulation techniques. So first we will learn the circuit diagram of Foster-Seeley discriminator. So before that we should know the basis of FM receiver. So FM receiver, it is an amplifier which eliminates noise in the received FM signal. This amplifier matches antenna to the receiver. In this diagram we have one transformer which is called as primary, and also another one part which is known as secondary. In the primary part we have one input capacitor, that is CP. The FM input is given as input to the capacitor CP. This FM receiver improves the noise figure of the receiver. The mixer here in the FM receiver, which is used to mix the different frequency levels. This converts or down converts the incoming carrier's frequency into IF signal. So in general, FM demodulators and discriminators, they are otherwise known as super heterodyne receivers. They have different types of demodulators or detectors. So here in this FM Foster-Seeley discriminator, it is used to find the phase shift between the primary and secondary voltages of the tuned transformer. It is the function of frequency. It can also be shown as the secondary voltage which lags primary voltage by 90-degree phase shift. So here we have one carrier center frequency. So this is motor CP. Inside this capacitor, this carrier frequency, which is termed as FC, that is which resonates the frequency of the transformer. Foster-Seeley discriminator utilizes the principle of FM detection or demodulation. So this figure, Foster-Seeley discriminator, which is shown as FM demodulator. So here this primary voltage is coupled through C3 capacitor, and it is coupled with CC to the secondary. So here one RFC is there, RFC which is used for coupling between primary and secondary. This is known as radio frequency choke. So this capacitor passes frequency of FM. Thus the voltage which is generated inside primary, which is V1, it is flowing across the secondary. So that is known as through the RFC cable, RFC. This RFC offers high impedance to frequencies of FM. So when this voltage F1 appears across the RFC, that is center taped secondary, and it is ground also. This voltage of secondary is V2, and it is equally divided as upper half and lower half of the coil. So here the center taped line divides the secondary part as upper half and lower half. So here this upper half and lower half, both voltage levels are same. Foster-Seeley circuit is probably most known as Foster-Seeley discriminator. This discriminator circuit is characterized by transformer choke and diodes. So here in this above figure, which here we saw that the primary tank circuit L1 and C1, and secondary tank circuit L2 and C2. So both circuits are tuned to center frequency of the incoming signal. When this choke is in the DC return path for diode rectifier D1 and D2, the resistors R3 and R4 are load resistors and bypassed by C3 and C4. To obtain different phases or different phased signals, a connection is made to the primary side of the transformer using the capacitor through the RFC. So it gives 90-degree out of phase. When unmodulated carrier is applied to the center frequency, both diodes are conduct and it will produce equal and opposite voltages. So here these voltages will cancel each other. So when the carrier moves off one side of the center frequency, balance condition is destroyed. So the diode conducts more than the other. So this is when the first frequency FC is greater. So this results in voltage across the resistor which is larger than the other. So resulting some signal at the output. So similarly, when FC is lesser, so in this condition also some difference voltage is there because both are not same. So there will be some voltage in the output. So whenever both frequency, both voltages are same, both will be get cancelled. So here in this diagram we can see the operation as one is above the frequency resonance and another one is at the frequency resonance, and the last one is below the frequency resonance. When this one is above the resonance means this vector diagram will be like this, that is it will like this graph. When it is at the resonant frequency, so it is it is in the perpendicular direction. When it is in the below direction, this angle will be greater. So this is like this. So advantages of Foster-Seeley discriminator is it offers high performance resonance linearity. It is very simple to construct the discrete components, and it also provides high output than the radio frequency discriminator. And while talking about the disadvantages of this Foster-Seeley discriminator, it does not easily incorporated with the integrator circuits, and the transformer cost is also high because of the narrower bandwidth. The ratio detector does not easily lend itself to bring incorporated within the integrator circuit. So we have one quiz question based upon this Foster-Seeley discriminator, that is in frequency modulation. The first option is given as amplitude of the carrier remains same, then frequency of the carrier varies in accordance with the modulating signal, and the number of sidebands are infinite, and all of the above. So in frequency modulation, this all things will happen, that is amplitude of the carrier remains same and frequency varies. So A part is correct, and B part is frequency of the carrier varies, that is also correct. Third one, number of sidebands are infinite, that is also correct. So three things are correct. So final answer is D part, all of the above. Thank you.